Okay, the product rule. So let's say if we have f and g are two functions that are differentiable. So if f is multiplied by g and we want to differentiate them with respect to x, so let's say f and g are in terms of x. If we want to differentiate fx multiplied by gx, so we will have fx and then we have to multiply by gx and then plus with gx and we differentiate fx. Okay, so to make it simpler, let's say we can say that we can let fx as u and gx as our v. So here fx is u, and if we differentiate g, so we'll have v prime plus, and g here is v, so if we differentiate f, so we'll have u prime. Therefore, if we differentiate two functions, so we'll have u v prime plus v u prime, and we're going to use this as a product rule to differentiate two functions when they are both multiplied by each other. So let's look at a few examples. We can do it together. Okay, let's look at this first example. So we have y equals to x plus 2 cubed multiplied by x minus 2 to the fourth. So what you have to do is first, we have to find our u and v. So now u is equals to x plus 2 power of 3, and now v is x minus 2 power of 4. So to use the formula dy dx, we know that earlier, u v prime plus v u prime. So we have to find u prime. U prime is 3x plus 2 squared multiplied by 1, and v prime is equals to 4x minus 2 cubed. And then we just substitute into our formula. So u v prime plus v u prime. And then we can simplify this by, so we have same terms here, x plus 2 and x plus 2, x minus 3 and, x minus 2 and x minus 2. So we can factorize, and then when we simplify, we'll have, so this is our final answer. You can pause this and do it by yourself. Next, let's look at second example. Okay, let's say we have y equals to x to the fourth multiplied by 2x minus 3 to the 6. So we want to find dy dx. Again, u v prime plus v u prime, or you can also write down as v u prime plus u v prime. Well, I suggest for you to remember this kind of arrangement formula, because we'll see it will be easier when you want to apply the quotient rule later on. So we have to identify our u and v. So this is our u and this is our v. U is equals to x to the fourth, and v is equals to 2x minus 3 power 6, and u prime 4x cubed, v prime. Okay, and then just substitute again v u prime. Now I'm going to use this formula, v plus u v prime. Okay, when we simplify this, again, since we have the same terms here, so we can factorize, and then we simplify. So this is our final answer. Let's look at another example, and this one will involve a radical function. So we have to identify our u and v. Now u is x, v is x cubed minus 2 to the power of 1 over 2. So u prime 1 and v prime 1 over 2 x cubed minus 2 negative 1 over 2 3x squared. Or you can write it down as 3x squared over 2 and multiply with x cubed minus 2 1 over 2. Okay, so we want to find dy dx vu prime plus uv prime. Again, we have to simplify this. So this will be nicer if we multiply with set x cubed minus 2. Okay, and then we have to expand this. So if we simplify, we'll have 5x cubed minus 2 over 2 set of x cubed minus 2. So this is our final answer. Let's look at another example, and this one involving trigonometric functions. So again, we have to identify our u and v. So our u is sine x and v cos 2x. So u prime, when we differentiate sine, you will have cos x. And if we differentiate cos 2x, we'll have negative 2 sine 2x. And then to find dy dx vu prime plus uv prime, just substitute and you will get the answer. You can simplify, but as you can see here, this is cos 2x multiplied by cos x. So their angles are not the same, so you cannot simplify this anymore. So this is our final answer. Okay, I'm going to show you one more example. Now our function involving exponential functions and log functions, but it's just the same. First, we have to identify our u. This is our u, this is our v. So if we want to find dy dx v u prime plus uv prime, so u is e to the power of 2x and v is ln 3x. If we differentiate exponential function, so you have 2e to x, you have to differentiate the function multiplied by the exponential function. And if you differentiate log function, so you have to differentiate the function first, divide by the function itself, 3x. So we'll have 1 over x. So dy dx is equals to ln 3x multiplied by 2e to x plus e to x multiplied by 1 over x. Or we can write it down as 2e to x ln 3x plus e to x over x. So with these 5 examples, I hope you can try it by your own, and I hope you enjoy this video.